Hi, in this video, we want to take a look at measures of dispersion in statistics. Okay, so when I have some data, the first thing I want to know, along the number line, where is my data? And for that, I'm going to use a measure of central tendency to tell me, just with a one number summary, where is my data? Now, next question I'm going to have is, how spread out is my data? And so for that, I'm going to use a measure of dispersion. Okay, so measure of central tendency tells me where along the number line. After that, measure of dispersion tells me how spread out it is. And so these are two numbers that summarize my data. Of course, a two-number summary is going to have a loss of information about like the nuance of the data, but this is a good place to start to try and understand and dig deeper into it. All right, so measures of dispersion are used in statistics to describe how spread out a variable set of data is. They are important because they provide information about the diversity of a data set, and they can help us better understand the data and draw more accurate conclusions. Here are some reasons why we use measures of dispersion. First, to describe the range of the data set, the range provides information about how far apart the extreme values are in the data set. It can give us an idea of the spread of the data, but it does not give us any information about the distribution of the data between the extremes, really. To understand the spread of a data set about the mean, the variance and standard deviation and the mean absolute deviation provide information about how much the data deviates about the mean. They can help us to identify if the data is clustered around the mean or if it's more spread out. Next use is to identify outliers. So measures of dispersion can help us to identify outliers or extreme values in the data set. Outliers can have a significant impact on the results of statistical analysis, so it's important to identify them and understand their effect on the data. And another one is to compare data sets. Measures of dispersion can be used to compare the variability of two or more data sets. The coefficient of variation, for example, can be used to compare the variability of data sets with different means. All right, so our common measures of dispersion, I'm going to scroll through and just list them first. Range, variance, standard deviation, mean absolute deviation, interquartile range, and coefficient of variation. Now, there are others, but these are the major ones that we interact with. And so the range is the difference between the maximum and the minimum values in the data set. It gives an idea of how far apart the extreme values are. The range is a simple measure of dispersion that is useful when the data set is small and there are no other extreme values. It can give us an idea of how far apart the extreme values are, but it does not give any information about the spread of the data between the extremes. All right, so I personally use this mainly when somebody's presenting results to me and they give the maximum and minimum. And so then I just subtract the maximum and minimum, and that kind of gives me an idea of where the of how spread out the data is. And another thing that we can do, we can use this range. If I divide it by 4, that gives me a rough approximation of the size of the standard deviation. And so that's because of the 2 standard deviations left and right, covers usually 95% of our data, and 95 is close enough to just say the range connects to it. But so if I take the range from like a preliminary data collection, a preliminary study, take the range and then divide by 4, then that gives me an idea of how big the standard deviation will be for my full-blown put more effort into it final data collection. And so it's useful for like pre-data figuring out what's going to happen. All right, so let's run through an example. Now, there are multiple definitions of the range. So the range in R means a 2-number vector of the minimum and maximum values. So if I want to take the range as I have it presented here, which is the difference between the maximum and the minimum, I need to run the difference function to run subtraction. And so we can see that we get a difference of 13. Now the next one is variance. Variance is the average of the squared differences from the mean, but this average is a little bit different. Instead of dividing by n, I divide by n minus 1. Typically, some statisticians will divide by n. There's advantages and disadvantages to both. So it measures the degree of spread of a data set about its mean. The variance and standard deviation are useful when the data is normally distributed, and the research question is about the degree or spread of the data about the mean. If you're going to be doing hypothesis testing, variance is going to be something that you're going to be mindful of. So even if you don't know it, you're going to be considering variance. Now, variance and standard deviation are sensitive to outliers and can be affected by extreme values. They are commonly used in hypothesis testing and to calculate confidence intervals. So variance primarily is what we use when we're doing theoretical work. And when I'm doing applied work with real data, typically we'll be using standard deviation. But there's times that we will, use both in other situations. And so in R, if I want to take a variance, it's just VAR, drop in the data vector, boom, we've got it. Easy peasy, lemon squeezy. Now the standard deviation is the square root of the variance. And so this tells us how much the data deviates about the mean. Now, if you look at that formula that we had a moment ago for variance, if I can squeeze it both in, you'll notice that there's a bunch of squaring going on with variance. So variance is its unit of measurement is the square of the original data's unit of measurement. All right, so if I'm measuring in, let's say, meters, all right, then my variance will be meters squared. My standard deviation, if I'm measuring in meters, my standard deviation will be meters. And so when it's nice that standard deviation uses the same unit of measurement as our original data. And so that's one of the reasons why we typically use standard deviation when we're actually analyzing real data. Now, the next one is mean absolute deviation. So the mean absolute deviation is the average of the absolute difference from the mean. So this is the average difference from the mean. It's less sensitive to outliers than variance and standard deviation. And the reason for that is because when we square something, so if I have a deviation, or if I have an outlier that's kind of extreme, well, when I square it, it's going to get even, the difference is going to be even bigger because of the squaring. And because of that, standard deviation and variance are very sensitive to outliers. Mean absolute deviation is still sensitive to outliers, but not as much. The mean absolute deviation is less sensitive to outliers than variance and standard deviation, so it can be a better measure of dispersion when there are extreme values in the data set. It is useful when the research question is about the average distance of the data from the mean. So I use this personally to be able to say this is the average difference from the average. And that's easier for people to understand, the average difference, than, squaring and then add it up and then take a square root. If I say average difference, then that's an easier thing for people to ingest, to understand. So it's a good choice to use that when your audience isn't comfortable with, the standard deviation calculation. And now in R, if I want to get the mean absolute difference, then what I do is just, subtract the mean from my data, take the absolute value, and then take the mean. Easy peasy, lemon squeezy. Now, there are packages in R that have it built in. I think that's simple enough of a calculation that it's okay to just do it manually. Now, the next one is the interquartile range. And this is the measure of dispersion that we typically use when we're looking at box plots. So here we're going to take the third quartile and the first quartile, subtract them, that is our interquartile range. And so this is going to be the difference between the 75th percentile, which is called the third quartile, and the 25th percentile, which is called the first quartile. So it represents the range of the middle of the data and is less sensitive to outliers than the range. So this is I take the 50% of my data that is the most middle possible in my data set. And then I take the ends of that middle 50%, do subtraction. And that is my interquartile range. So this is by far, of the ones that we've talked about, the least sensitive to outliers, and it's less sensitive to outliers than range and standard deviation and variance. And it's useful when the data is skewed or it contains extreme values. And we use this every time we look at box plots. All right, and so for our example, once again, I've got my data, and I just use the IQR function because it's the interquartile range. Boom, it calculates it for me. Now you'll notice that all of these are giving slightly different numbers on the measure of dispersion. And so what's important for us is that we understand that each of these are a different measurement of dispersion calculated different ways. When I talk about like someone being athletic, we could measure athleticism with like how much they could bench press, or we could measure it by how fast they are in a marathon. Those are two very different measurements of athleticism. And so just like with data, different measurements will come up with different conclusions. And now someone who is overall globally athletic will have a decent bench press, they'll have a decent, 5K run time, and they'll, you can tell overall that the person is athletic. Now, when I have data, when data is highly dispersed, it's going to be obvious because all of these will give a large number relative to the location of their data along the number line. If it has very little dispersion, then everything's going to be pretty tight around the central tendency. Now, the next one that we want to talk about is the coefficient of variation. The coefficient of variation is the ratio of the standard deviation to its mean. It's used to compare the variability of two or more data sets with different means. All right, so now think about the situation where we want to compare the variability of two data sets, but the two data sets are just on very different magnitudes. So let's say I want to compare the dispersion of planets with asteroids. Well, planets are probably going to be bigger, right? So just off of the sheer size of planets, what's going to end up happening is that planets are going to just the measurement of dispersion is going to be so much bigger, not because they're really dispersed, but because they're just bigger numbers in the first place. And so how we counteract this is that I'm going to take my standard deviation like we talked about, I'm going to divide by the mean, and then I'm going to multiply by 100, and that's going to give me like a comparison of dispersion where things along the number line are not being considered. So here, it's like, what is the shape? I'm trying to measure the shape of the dispersion, not the actual value itself. It's on this. And so the coefficient of variation is useful when comparing the variability of two or more data sets with very different means. It's commonly used in quality control and reliability analysis. And so to execute this, I do standard deviation, divide by mean, multiply by 100. Easy peasy lemon squeezy. And so here I have these two data sets, and I can compare them very easily. And we can see that, this data set is shifted to the left, or sorry, this is shifted overall to the right of this data set. And so they have different central tendencies. This one has naturally bigger numbers, but that doesn't mean it's really relative to its mean that much more spread out. And so here, these numbers show that the first one, relative to its mean, is more spread out. In summary, the choice of measure of dispersion depends on the nature of the data and the specific research question. It is important to choose an appropriate measure for accuracy describing the spread of the data. All right, well, that's all I've got for you. Life is short. Do math.